this video I'm going to talk about how to draw the Lewis dot structure for ozone, which is O3. So without wasting of time, let's start. Why this is plus and minus charge and how to draw the Lewis dot structure. So for draw the Lewis dot structure, first you need to write the formula and you should know what is the formula. So formula is given that it's O3. So to write the Lewis dot structure, there are certain rules. So we'll follow the rules. Rule number first state that you have to count the number of valence electron, total number of valence electron. So if you think the O3, how many valence electron total we have? We have for one oxygen, what is the configuration? We have 2 and 6. So total valence electron will be 6 into 3, which is 18 electron. Done. Now after counting the valence electron, what we have to do? We have to make the bonding. So there are 3 ozone oxygen atom, so let's make at least single bond and we'll count. Okay, after forming one bond, so start always with first bonding. How many electrons pair are involved in the bonding this oxygen atom? So total bonding electron will be, since there are 2 bonds 1 and 2, it will be 2 into 2, which is around 4 electron. Why I have written 2? Because when we write like one stick, it means there are 2 electron pair are shared. So this represents the 2 electron pair, so that's why this is done. So total, now how many electrons are left over? It will be 14 electrons, so that will be our lone pair of electron. So now we have around 14 electron, which is lone pair. Let's start arranging them from the corner atom. You always start from the corner atom. Okay, so let's start from this oxygen. So here I need to write from fresh. So let's write from the fresh. This is oxygen. I have put one bonding electron, one bonding electron. Now we need to arrange this 14 electron. Let's start here. 1 2 3 4 5 6, and this is 7 and 8 because this is represent 1 electron. So always we need to arrange this lone pair electron in such a way that every atom satisfy the octet level. Now after arranging the 6 electron, still we have around 8 electron. So let's organize this also. 1 2 3 4 5 6. So 6 6 12. Now we have 2 electron. So 2 electron we can put it here. Now if you look this structure, we will ask the question that yes, this is octet, this is octet, but what about this oxygen? Is this also octet? No, right? Let's count it down. 1 2 3 4 5 6. There are 2 electrons which are deficient here. So now what we can do here, that remember this lone pair electron, what I have written here, it has 2 purpose. First you should make a octet. So first try to make a octet for the atom. Octet, how it will form? By forming double bond or triple bond. Okay, now if it is satisfied, then the octet, the remaining lone pair electron will be remain as it is. Now here, what if I'll move this electron here? What will happen? So when I move this electron here, now this oxygen will have, count it how many electron we have. So this will be now 4 electron here, and this will be 4 5 and 6. So now let's count. This has octet. Yes, this has octet. Let's see. 1 2 3 4 5 6 7 8. Yes. What about this oxygen? 1 2, and there are 3 stick, 3 bonding. It means there are 3 into 2 6 electrons. So yes, this is also have an octet. It means this structure is a correct structure of the Lewis dot structure because every atom had the octet. Now we have to also think about the formal charge, which is another important parameter to determine the stable structure. Like, is this structure what I have written, is it correct? What is the formal charge over you have? So let's talk about little bit about the formal charge. So basically formal charge, what we see is not actual charge. It is a hypothetical charge, which is assume it's hypothetical charge, and it should be minimum. It should be minimum, or if it is 0, that will be the best, or 0, that will be the stable Lewis dot structure. How to count it down? There are some formula of the formal charge. So formula is said that the charge will be valence electron minus lone pair electron minus bond per electron divided by 2, and this you have to count for each atom. So let's count about this oxygen just now what we have made, and this oxygen, right, that what is the formal charge. Count for first, second, third, and arrange that electron how it was. So it was like this. Now let's count for first oxygen. What is the formal charge? So valence electron oxygen, you know it is 6, minus how many lone pair electron we have? 6, minus what is bond electron? 1 means 2 electrons. So 2 into 2 divided by 2, it will be cross it here. Sorry, it will be just just 2, because this is just one stick. So this is just gone, minus 1, this is done. So it will be minus 1 charge. Now let's talk about oxygen number 2. Valence electron 6 minus lone pair electron 2 minus bonding 1 2 3 bond. It means 3 electron pair, which is 3 into 2 by 2. So 2 is cancelled out. 6 minus 5 will be plus 1. Now let's talk about the oxygen number 3rd, which is valence electron 6 minus lone pair electron we have 4 minus bond pair electron we have 2 into 2 divided by 2. So it will be 6 minus 6, which is 0. So now this oxygen, what we have gone, one oxygen is minus 1. This oxygen number 2 is the plus 1. Oxygen number 3 is 0 formal charge. So if you think the total overall charge, the formal charge total, it's a 0. So always think about total formal charge, how it is, how much it is. So it's a 0. So this molecule will be stable. This structure is good and stable because overall formal charge is 0. Now what this formal charge state? The formal charge just give you about the idea where is the valence electron located, or how many valence electron is present in that particular atom. So for this oxygen atom, if you think they are minus 1, it means represent that they have extra valence electron which is here, and this is plus 1. So here we need to understand that overall formal charge is 0. That's why whenever you write O3, right, we don't write any charge over there. These are just neutral molecules. This just tell about the valence electron location in these molecules, but overall they are not like ionic molecules. Now one question I would like to ask you, the ozone structure we can write in the two ways. What are the two ways I can write it down? So two ways I can write it down. The one way just now we have drawn, that you can write, okay, this is O, O, O. So this was 1 2 3 4 5 6. This was 2, and this was 4. 1 2 3 4. Then and we have written plus and minus. I can also write this structure as this double bond. I can shift it here, and I can repeat the same structure, which is looks like exactly replicate, plus, and I can write this. So left is shifted to the right. Now I can write this or this, and both is correct. You will be surprised to know that the actual ozone structure is in between the structure. What I mean, that when you will assume that this is structure A or second, which is better. So this single bond structure, this bond length is around 148 picometer. The double bond is 121 picometer. So we will assume that ozone actual structure might be this, but experimentally it has been proven that ozone structure is neither 121 neither 141. It is between oxygen single bond and oxygen double bond, which is around 128 picometer. So if you look the ozone structure, basically this length is same in both of them, in both oxygen, which is 128. So the structure which have all the bond length is same regardless it is double bond or single bond, that structure is called resonance structure. So here the structure 1 and 2 represent the two canonical forms, while the structure 3rd, which is here, this represent the resonance hybrid, which resembles the structure 1 and structure 2 as well. I hope you understood how to draw the Lewis structure of ozone. If you think this is good video, share it with your friends and let me know in the comment section what difficulty you find in drawing the Lewis structure. Thanks for watching.